Alright, so this is my vintage SNK Neo Geo MVS arcade cabinet, and it's got a K7000 cathode ray tube display. And as you'll see, when I plug the machine in, the marquee comes on, the machine comes on, and even when I give time for the tube to warm up, there's no display. Now, I've just made this video to give you a couple of tips before you shotgun this board. There are plenty of videos out there, plenty of resources and information on these K7000s, and I'm not going to be able to do any better of a job than a professional at showing you how to do this. I'm just going to give you a couple of little tidbits of advice for approaching these repairs, especially if you're a beginner. So first thing we're going to address here is safety. Now, if you go to Google and type in how many volts in a CRT, you can see that it's nearly 30,000 volts. And I promise you, this can kill you, and it will hurt the whole time while you are dying. So please take some personal responsibility for your own safety. Once again, there are plenty of videos out there made by professionals who could do a way better job than me, and I recommend this one right here. And if you aren't confident that you can discharge this CRT and perform this work safely, then for the love of God, don't do it. Now, that being said, so I just reached my tool underneath the anode cap and ground it to the chassis. Now, these are supposed to have like a resistor that auto discharges whenever you shut the monitor down, but what if that circuit has failed? Or what if my research is wrong and this particular chassis doesn't have that? So once I've discharged it, I go ahead and unhook the anode cap. And I slide the neck board off. And then I go about unbolting the board from the chassis. Then I just go about unplugging everything, and then I just wrestle the whole board out of there. My advice is take plenty of photos of where everything plugs into the board, because you could have trouble plugging it all back in the right places when you go back to reinstall it. Then I just go ahead and unscrew the board from the standoffs. And now comes that little bit of advice that I promised you. The two most common parts to fail on this board are your flyback transformer, which is located right here, and your horizontal oscillating transistor, or HOT, which is located right here. It's attached to the heat sink which shrouds the flyback transformer. It's very easy to find, and it can be tested in circuit with the regular multimeter. And the reason it's attached to this giant heat sink is because this component generates a lot of heat, which is the enemy of electronics. And in my opinion, this part probably takes the most punishment on the whole board, and is also the part that's most likely to fail. Now, once again, there's no reason for me to rehash how to test a transistor. Just go to YouTube, type in how to test a transistor. There are professionals that have done a way better job than I can at showing you how to do it. But it's a cakewalk, and no reason you shouldn't. Now, why am I telling you all of this? Well, there are a ton of great resources out there on how to repair these monitors, and most of them are made by professionals who are better than me. But what I found is that during their videos, they'll say, well, if I'm going to replace one thing, I'm going to go ahead and install the cap kit, or I'm going to go ahead and replace this and this. And they're going to shotgun the whole board and replace everything. Now, shotgunning the board or loading the parts cannon is when you just replace every single piece that could possibly have failed. And this may be a great approach if your business is repairing these boards or refurbishing them. You know, your customer is going to get back a like new functioning board, and you get paid for replacing the parts. But here's my advice. If you're a novice and you've never desoldered and replaced components from a circuit board before, it is a skill and it takes practice, and you're likely not going to be so great at it your first time around. And if you tried to solder every single component in this board and you mess one up, or mess many of them up, how are you going to find your mistake? So my advice to you is to learn how to diagnose a couple of the individual components, and I would start with these two most failed components. Then if you have to troubleshoot your own mistakes, when you're done, you've narrowed the field and you'll more easily be able to find out where you messed up. And then if you get your monitor working and you decide you want to install a cap kit or whatever, then you can do it at that point. So we're going to go ahead and replace this flyback transformer, and I like to use this butane powered soldering iron. It's a Portasol made by Weller, and I think they've discontinued it, but I think they offer an updated model. And there are plenty of videos out there, like I say, on desoldering and replacing components. And, you know, they've done a much better job than I can do. And I'm not a pro. I do this once every 2 or 3 years. And I was going to show you this solder sucker. And the one I have is junk. And it actually failed right here during this video. And I couldn't even get it to spring back. So I've always had a lot more luck with a desoldering braid, and I'll show that to you. So if you guys have a link you want to post to a affordable solder sucker that actually works, please put it in the comments. I have a feeling that this is just a poor quality one, and it's never worked well for me, and now it's finally failed. Okay, I'm going to cut off a piece of this desoldering braid. And the idea behind this is that it's just a piece of copper wire, loosely braided copper wire. And the idea is, I'm just going to rub some flux on it here. And the idea is to coax the solder to stick to this braid so you can pull it out of the way. Now I've sped up the footage, and of course most of this footage is superfluous at this point. There are tons of videos out there on desoldering and replacing electrical components in printed circuit boards, not to mention videos about specifically replacing this flyback transformer. So all I'm doing here is just desoldering each of the pins on the flyback transformer so that I can pull it off the board. Then you just put the pins on the new transformer through the holes in the board. Now I'm just applying a tiny bit of flux to each of the pins. Now I use rosin core solder, and the rosin in the solder is a fluxing agent if you Google it. And I've gotten into spirited discussions about these things with people from work. You can admonish me in the comments, because what I've found is that if you use flux in addition to the rosin core solder, it just sucks the solder into the joint much better, and you're much less likely to get a cold solder joint, and you can apply less heat to the board, and heat can really damage these boards, and it can damage other components on the boards. You can bake the traces right off of the board. And here I am just desoldering that horizontal oscillating transistor so I can replace it. And the other thing that you'll see me do, and you could admonish me in the comments, is that I will apply solder directly to the tip of the soldering iron and then apply it to the pins. And any electronics engineer or anybody that's book smart would admonish me for that. Everybody knows that you're supposed to heat the component or heat the joint until it's hot enough to melt the solder and then apply the solder. But once again, if you put too much heat into that board, you're going to damage it. And I've also cooked the insulation right off of wires trying to get the copper hot enough to accept the solder. So, you know, do your own research and practice and do what you want, but this is what works for me. Now, if you have any advice for me, put it in the comments. Now I'm just using some electronics cleaner and a toothbrush to get all of the flux off of the board. The flux is an acid and it'll corrode the board over time, so you want to get it cleaned off. So all I'm doing now is just screwing the board back onto the standoffs. And then I'm just reinstalling the chassis back into the machine. Installation is literally the opposite of removal. Then I'm just hooking the wires back up. Then I took a mirror off the wall and I propped it up on the jukebox here, up on this chair. Be careful not to drop the mirror, that would be a catastrophe. Then it's time to switch this puppy on. Of course, I plugged it into the wall off camera. I've had it unplugged for the duration of this work. And the reason I put that mirror up there is so that when I do my picture adjustments, the Flyback transformer has 2 knobs on it, and then there's a bunch of knobs on the neck board, and you have to adjust these knobs from the back, and so you can watch in the mirror while you adjust your picture. Now you can also grab your manscaping mirror out of the bathroom and kind of do the same thing. Or you can watch in the mirror while you adjust your picture.